Good day. It's a great pleasure to be able to speak to you today on behalf of the Global Alliance and talk about this incredible moment in time when cloud genomics really comes into its full being. Genomics is growing at a space where some commentators have even suggested we should use the word genomical rather than astronomical to describe really large data sets. It's not just the genomic data, it is the phenotypic, the clinical data that has to go with it to make sense of it. So when you think of big data, think genomics, but think of all that other human data that goes alongside our genome. Just to make that point a little bit more, there are over 3 billion people on Earth today do online banking. There are over 3.5 billion people have mobile phones. I'm assuming almost everybody in this audience has both. But all 7.9 billion people on Earth have a genome. And the size of that individual genome, 3 billion letters, means that one human genome is equal to 10 Encyclopedia Britannicas. The big question for all of us is how many of those genomes that will be generated over the next 10, 20 years will be put in the cloud? And I think the trend is very clear. It's increasing. And it's partly the size of the data and it's partly the nature of the data that says cloud is the environment to go in. There is a fundamental shift. In the past, very expensive genomes have come from research. Moving forward, increasingly cost-effective genomes will come from healthcare. The combination of those massive data, cloud is a great option. We're tracking today over 200 genomic data sharing initiatives globally. They fall into 4 separate buckets with some overlap, but some are truly in clinical and genomic medicine, others much more traditional research. 20 plus of them have got a national label. These are big things that have been announced at a very high political level and have got some national identity and pride behind them. And then there are cohorts, some of them have been around for 10, 20 years, that are now just starting to lay down genomic data. The reasons for sharing any kind of data, and I think more than anything else, COVID has showed us just how important it is to share data internationally and to share it as quickly as possible. But with genomic data, part of the key to sharing is that we only understand a fraction of those 3 billion letters. We can read them all, but we hardly know what most of them mean in terms of human health, in terms of human identity. So the reason for sharing the data is so we can unravel the complex mysteries of the genome. With that, we have to take a shift from a traditional approach to data sharing in genomics, when we had small numbers of genomes in a few centers, where data copying was the paradigm. And today we're thinking that data sharing will much more go from data copying, data downloading, to data visiting. It won't be all one approach for every type of genomic data. When we've been able to translate that data into knowledge, then we can share it in centralized genomic databases. Data is smaller, it's publicly available, and it's true knowledge. It can be available on your smartphone. As we move progressively closer to identifiable human data and clinical data, then more and more we have to think about ways of protecting that data, securing the data. And the larger the data gets, the more we have to leave it in place. So we think about federation as a key. And as we move along this continuum from the idea of data commons, where you aggregate the data, download it, analyze locally, the tradition, moving into cloud commons, where you aggregate the data globally, you analyze it in a secure cloud, all the way to federation, where you leave the data locally in the jurisdiction it was generated in, and you visit that data remotely and you collate the results. Much more important the closer we get to health data. GA4GH was founded in 2013 as a global alliance. Although it came from the research community, it was never just about bigger, better genomic research. It was always about bringing that genomic research closer to healthcare and closer to impacting human health. We have many objectives and ways we achieve it, but I'll just say we focus on international data sharing on across that translational continuum, federation as an increasing approach, and a huge focus on interoperability between different environments. From the beginning, our work has been based on an ethical policy framework called the Framework for the Responsible Sharing of Genomics and Health-Related Data. You can see here on this slide, it has foundational principles, it has some very clear aims, but the two takeaways that I'd like to leave with you on this framework is it's based on two fundamental human rights. The right to science, so all citizens having a right to benefit from science, and the right to recognition, so the right of scientists and clinicians to benefit from recognition of their work. Two fundamental human rights. And based on that, we're pushing really hard to talk about responsible data sharing and balancing the tremendous benefits against the potential harms. And that framework of responsible data sharing is something that we've taken forward and drilled down into many tools and protocols that lie underneath this organizing framework. Our ecosystem today is over 600 organizational members. About half of those are industry rather than academic. 3,000 plus individual contributors, subscribers, operate in 90 countries, 8 work streams, 24 driver projects. Work streams are inside the Global Alliance. Driver projects are external. They will include many of the groups you're working with, people who have genomic data. We've produced so far 20 technical standards, 7 regulatory policies and frameworks, and there are over 40 implementations. The big thrust of all this effort is to enable a global learning health system. This schematic really just lays out the organization of Global Alliance. 6 technical work streams, one of which is cloud, 2 foundational ones, one on regulatory and ethics, one on data security, 24 driver projects in the areas of rare disease, cancer, national initiatives, basic biology, complex diseases around the world, all of them either international or with an intent to share their data internationally. Those 24 are our proxy for the 200 plus genomic data sharing initiatives. Beyond Global Alliance itself, we collaborate with many other groups on this page that are working hard to bring this genomic revolution to its full potential. From the Beyond 1 Million Genomes project in Europe, through work that's been focused on COVID and infectious disease, through cohort consortiums, and through a new initiative focused on creating a new reference genome, a graph-based reference genome for all humanity. But the closer we get to healthcare, the more imperative it is that Global Alliance links with established standards organizations such as HL7, HL7 FHIR, SNOMED, CDISC, and ISO, because those are the standards that are used inside industry, inside healthcare. And so as we bring these new genomic standards to bear, we're very clear that we need to map them, translate them, align them with standards that communities are already using. I mentioned our cloud work stream. It's one of 6 technical work streams. When we started the Global Alliance, there were only less than a handful of examples of genomic data in the cloud. The NIH had a policy not prohibiting data being in the cloud. Today, cloud is the first choice for many people in many settings for all the reasons that you would know. So our Global Alliance work stream is looking at workflow execution, tool registry, data repositories, task execution, cloud testbeds, and now starting to create an environment in which many of our other standards can be brought together. We have a short video that brings to life many of the points I've just made in this talk, and I can do it in a way that is succinct, is modern, progressive, and I hope you enjoy this video that in one short, succinct way tells a story that is worldwide, it's global in its appeal, and it's the way to move forward in this incredibly exciting field of genomics.
University Hospital is a global leader in infectious disease research. Anna is a member of the UH faculty, where she leads a team in studying a deadly pathogenic disease. Like many of her colleagues, Anna would like to work with more datasets around the world in order to analyze the genomic and health-related data of as many patients as she can. in order to identify genetic variants associated with better outcomes and guide better clinical treatments. Similarly, UH and institutions like it want to make their troves of data available to researchers like Anna. But without interoperable methods for researchers to efficiently identify, access, and analyze data of interest to them, none of this is possible. Right now, Anna's team can easily interrogate local UH data, but working with datasets around the world is challenging. Without large interoperable cohorts, the statistical significance of their results remains low, limiting their ability to advance the field. But it doesn't have to be this way. A suite of software tools powered by GA4GH standards can connect researchers like Anna to a global network of data in a secure and responsible way, unlocking its potential to benefit human health. First, the GA4GH discovery APIs allow data stewards to make their datasets findable. Anna can query this large network to identify datasets that are relevant to her study. For each dataset she wants to analyze, Anna works with the corresponding data access committee to acquire permission. GA4GH standards help these groups to reliably determine whether Anna's proposal is within the scope originally agreed to by the data donors. Her approved requests are added to her virtual identity. And now she can begin working with the data. With the GA4GH Cloud APIs, Anna's lab is transformed into a virtual hub, connecting her to all the data she needs to do her job well, although she will instruct software machines to carry out much of that work on her behalf. Anna tells each machine where to go, what data to analyze, and which analysis tool to use. Equipped with these instructions, the software machines head out to analyze a portion of the data right where it sits. Only machines with authorized access to this data are allowed to enter. The machines carry out Anna's instructions, which is made possible because the institution has packaged its data in a universal way, also according to GA4GH Cloud standards. Each machine brings back its analysis result to feed into Anna's study. As a security measure, the data steward may remove access from Anna's software machines once the analysis is complete. Anna's team fits the pieces together to reveal a genetic variant associated with better outcomes, a new insight they could never have seen if the datasets were not interoperable. Anna is just one researcher, but her story isn't unique. Someday, we hope that every researcher in the world can access a global network of data from the comfort of their lab, revealing otherwise hidden knowledge of human health and disease.
Thank you. I hope my talk and that video give you a sense of where we are in genomics today at a global level. It is probably the most exciting time to be in genomics. We'd thought for many years, as we saw this massive amount of data starting to emerge, that it could be overwhelming, a tsunami of data, and that we wouldn't be able to keep up with it from a technical point of view. So we organized in a way to try and turn it into a treasure trove of data that could be available to humanity. And the key to doing that in many, many instances is the use of federation and the use of the cloud. Thank you. And in any way you can, please join us and be part of this exciting future of genomics.